Now, in vector algebra, first let's discuss addition and subtraction of vectors. In this one, first we discuss graphical method. Later on we will think about the algebraic method. Okay. Now see here. Method of triangle for addition of vectors. There are two methods, triangle method and parallelogram method. So first we discuss triangle method. Okay. Now see, suppose we have two vectors, vector A and vector B, and we want summation of these two vectors. So here what we have to do, first we have to prepare one vector OP, which one is in the direction of vector A, means parallel to vector A, and magnitude of this vector OP, that should be exactly equal to magnitude of vector A. Then in equality of vectors, we studied this thing, we can say now vector OP that is equal to vector A. Clear? Okay. Now see, so we can write now this vector A and this vector OP, that is same one, so we can say vector OP that is vector A. Similarly, if we prepare another vector from the head of vector A, this is head of vector AP, that is. So from that prepare another vector PQ, which is parallel to B, and magnitude of PQ that is equal to magnitude of B. So we can say this vector B and vector PQ both are identical one. So we can say vector PQ that is vector B. Now if we prepare here the vector joining to the tail of first vector A and head of second vector B, so that is vector OQ. So we can say this vector OQ that is vector R is the summation of these two vectors A and B, or we can say it is the resultant of vector A and B. And here see, triangle is formed, so it is known as method of triangle for addition of vectors. So in general here we can say this thing, if we want summation of these two vectors, then we can do one thing, take one vector from any point and then place another vector from the head of first vector, and then prepare the vector joining to the tail of first vector and head of second vector, that is the resultant of these two. So we can say this is the triangle method for addition of vectors, and sometimes it is also known as head to tail method. Now see here, vector addition that is commutative. So if we take vector A plus B or vector B plus A, the result that will remain same one. Now associative law. So here see, suppose we have three vectors, vector A, B and C, and we want summation of these three vectors. Then here first we place vector B at the head of A, then vector C at the head of B, then the vector joining to the tail of first one to the head of last one will give you resultant one. But here suppose first we take the summation of A and B. So A plus B will give you resultant OQ. Then in that if we add C, or suppose first we take summation of B and C and then we take the summation of it with A, then resultant answer will be same one OR, and that easily you can understand from the figure. It implies that if you take first A plus B and then add C in it, or if you take first B plus C and then take summation of it with A, your result will be same one. So we can say addition of vectors obey associative law also. Clear? Now see, now method of parallelogram for addition of vectors. So see here, suppose we have two vectors, vector A and vector B, and we want a summation of these two vectors. Then what we have to do? First of all, we have to represent both these vectors A and B from the same origin. So here arbitrarily we consider any point O, and from O we prepare the vector OP, which is in the direction of vector A, and its magnitude is exactly equal to magnitude of vector A. So OP, that you can say it is vector A. Similarly, from O prepare vector OR, and direction of OR, that is in the direction of B, its magnitude that is exactly equal to magnitude of B. So we can say vector OR, that is vector B. Now what we have to do? By considering these two vectors A and B as two adjacent sides, prepare a parallelogram as shown in the figure. So here by considering this OP and OR, two adjacent sides, the parallelogram OPQR is prepared. And see here, this parallelogram is prepared here, therefore it is known as method of parallelogram for the addition of vectors. Now prepare a vector OQ. So the diagonal from the origin that will give you the resultant of these two vectors means vector OQ, that is the resultant of A and B. So we can say that is vector A plus vector B. So OQ, that is A plus B. Clear? So now see here, if we think about head-tail method, then we can apply that method for the addition of multiple vectors. Now here what we have to do, suppose we have large number of vectors A, B, C, D, E, F, G, like that. And if we want the summation of all these vectors, then simply we can use head-tail method. Now how? Suppose we have so many vectors like this. So arrange all the vectors head, tail, head, tail, head, tail, head, tail of each other. See, this is vector A. From the head of it, vector B. From the head of it, vector C. Then from the head of it, vector D. In this way, arrange all the vectors, and then after prepare a vector joining to the tail of first one to the head of last one. And this particular vector joining to the tail of first one and head of last one will give you the summation of all these vectors. Now see, one very important thing easily you can understand here. If head of the last vector superposed to the tail of first vector, it implies that if we arrange these vectors head tail, head tail, head tail, and suppose a loop, closed loop is formed. So if this head of last one fall on the tail of the first one, then the closed loop is formed. Then remember this thing, the resultant of all these vectors means the summation of all these vectors will come to 0. Clear to all of you? So in this way we can prepare the summation of multiple vectors. Now subtraction of vectors. So actually subtraction of vectors, that is what? So subtraction of vectors means suppose we have vector A, vector B, and we want subtraction of these two, means A minus B. So here we can say this thing, subtraction of two vectors A minus B. That is mathematically we can write vector A plus vector minus B. So A minus B, that is nothing but summation of vector A and vector minus B. So now here easily we can understand this thing what we have to do, right? Suppose we have two vectors, vector A and vector B, and we want A minus B. So here we discussed A minus B, that is nothing but A plus minus B. So first here we have to prepare a vector which is minus B. So minus B, that is the opposite of B. So here see, this is vector B. Now minus B, that is anti-parallel to it and having same magnitude. So minus B is prepared. Now take the summation of A and minus B by head-tail method. Okay, so here vector A is prepared OP, and from the head of vector A. So from P, vector minus B is represented. So vector PQ, that is vector minus B. So we can write now vector OP plus vector PQ, that is equal to vector OQ. But OP, that is vector A, PQ, that is vector minus B, so that is equal to OQ. It implies that vector OQ, that is vector A minus vector B. So in this way we can take the subtraction of vectors. But now here easily you can understand this thing, vector A minus vector B, and if we take vector B minus vector A, then these two will not be equal, right? So here we can understand this thing, A minus B is not equal to B minus A. Clear बच्चों?